Okay, we are back for part two. As is customary, I'm going to kind of do a quick recap of what we're doing, where we've got to, and then kind of walk through the code, throw some comments down and clean things up a bit. So let me zoom in slightly actually. So what we're working on today is a clone of Lunar Lander, which is a game, a kind of physicsy game where you control, it's normally a kind of spaceship, but we're using our engineer character from Steamhounds here, because he's got these kind of steam jetpack things, which are kind of in line with that whole Lander theme. So what I can do is I can blast off here, and then I can kind of rotate the guy around. I can thrust in different directions, and the aim of the game ultimately is to safely land like on another platform without like flying off the screen or, you know, running out of fuel or landing upside down or something like that. It's one of those deceptively hard, like old school arcade games, and it was normally like really harsh about how fast, or rather how slow you had to be like as you hit the ground in order to not crash and actually get a safe landing. So that's what we've got now. So the basic physics are there. I can take off, the animation transitions are working. The one main thing we don't have still is any kind of collision detection, so I can just fall straight through this terrain, which should lead me to my horrific untimely death, but in fact just sends me off into the abyss instead. So let's get into figuring out how we can detect collision with this terrain and the slightly more tricky factor of how we know when we've just landed safely on like a flat piece of terrain. So I think the first thing we kind of need to do is what's going on here? There we go. Let me walk through the code actually before we get to implementing anything new. So we've defined a few constants up here. So these are just sort of tweakable sort of tuning parameters for the feel of the game. The way we've defined the terrain here is we have an array which just contains, if we have our whole screen, it just gives us a list of height values. So, you know, maybe it's something like this. And it figures out how those should then be like spread across the screen. If you give it more points, it will just kind of bunch them closer together, so that more or less does what we'd hope it would do, and then we can kind of join those together. There's the actual landercraft, so we kind of define our terrain, and then we spawn our lander at a certain position. This first little bit of the draw loop is just to count how much time has elapsed since the last frame was rendered. So that will then scale all the physics and game speed based on that. Then we update the lander, which I'll dive into in a second, and then we kind of draw the terrain. And the way we draw this is we figure out how many points are there, and therefore, you know, and how wide is the screen, and therefore how far apart should they be spaced along the x-axis. And then we just kind of use this begin shape and end shape feature of processing to just say, here are all the points. So the point of any height of any given terrain is in the array, we're holding its height kind of above the ground like that. But in processing, the 0 point, the origin is actually here. So we actually kind of need like this measurement, which is equal to height minus, you know, this size here, which gives us this like y coordinate where we want to draw this point. So we just throw that in as a vertex, and then it connects them together with line segments for us. Then we actually draw the lander here. So the update code, so we have a little state machine thing going on here. So this is no longer actually accurate. So what we actually have is we have like a takeoff. You know what, actually let me redraw this whole thing. So we have a grounded state. We then have a takeoff state. Yeah, right. Do you like my do you like my artwork here? So we go from grounded to takeoff, and then we go from takeoff to flying. What we probably ultimately want is actually like a landing state, because we have a little animation. So flying can take us back to landing, which takes us ultimately back to grounded. Or this is the nice loop, right, of like taking off, flying around, and then landing nicely. But if things go terribly wrong, we can actually end up dead. We can just get super exploded if we don't land correctly. So these are all the kind of states that our engineer can have. And right now we've implemented a few of these. We need to handle this transition between flying and landing and flying and dead ultimately. I know, right? This is some good stuff right here. This is prime programming excitement. I mean, to be fair, what do you expect programming to look like? Well, at least there's diagrams, right? Yeah, so to detect these collisions, we kind of need to figure out a couple of things. I'm going to screenshot this because it will help for diagram purposes. So we've already kind of, conceptually, we know like there's like a circle drawn around this guy. Let me draw that again, actually. You want UML? There, that's as close as I get to UML. Oh. Okay, I lie. There are parts of UML which I do use, but generally speaking, it can be a bit old school. I'll give you hacking stuff together with like a load of global variables until it works, and then ending the stream. How about that? Yeah, so we have the beginnings of this lander clone. Creatix, if you just... I'm not sure how long you've been lurking around for, but if you just popped in, we've got the basic physics with this thing working, some basic like animation, sprite sheet stuff happening, and what we now need to happen is for the thing to explode when it hits the ground. So we need to get into some kind of collision detection of some kind here, and we're modeling, you know, in the typical mathematicians or physicists way, we're modeling this guy as a circle because that's just way easier than any other way of modeling him. So I think what we need to do is, yeah, I'm going to screenshot this again. We kind of now need to detect. So we've defined this terrain as a series of height values, and we've drawn these lines between them. But in order to detect collisions, I think ultimately what we need to do is figure out when this circle here intersects with one of these line segments here. And there are several ways to do that. I took the liberty of, you know, my diagram skill is not amazing, so figuring out like an approach to this, which I think should work nicely for us. The gist of this is, okay, it's something like this. So we have these, let's use this big old line segment because it's kind of convenient. So this has like a start point and an end point. And then we have our okay, so to determine if a circle is colliding with this line, it's kind of equivalent to saying what's the distance between a point and the line, and if that distance is less than the radius of the circle, then we know that they're colliding, like they are in this case, or if the distance is bigger than the radius of the circle, then they're not overlapping and they're not colliding. So this kind of devolves to, I suppose, what's the distance between a point and a line or a line segment. Let's call this P. So I'm drawing lines because this is physics, this is collision detection, right? If we want to know when our guy has crashed into the ground, we essentially need to know when he's like touching this line, which boils down to, yeah, how far away is a point from a line, right? If we're like way over here, then obviously we're not like touching this line at all. But if we're like somewhere in the vicinity, then we need to know if we're touching it, given like the size of the object which we're talking about, which in our case is this guy over here. So ultimately, I'm pretty much going to copy and paste some code to do this because it's kind of a standard thing, but conceptually what's happening is we're saying, okay, here's a point. Let's find, let me draw this another color. Let's find, let's find a line. Oh, let's find a line which is kind of perpendicular to this, so it's at 90 degrees. So let's kind of find the normal, and then let's measure this length. The one case where that doesn't work is if the point's out here. What that will actually kind of do is like, you know, it's as if this line was extended infinitely in each direction, and it will just find some normal like that, and it will tell you that that's the distance. So you kind of need to say, okay, if it's outside of the bounds of this line, then the closest point is actually just this one here, right? Or this one. So basically, if we're within like the scope of the line, then we're going to just find this sort of this normal and measure the length here, and that gives us the distance. Otherwise, if we're like outside of the bounds of this, then we're just going to check the distance to like the endpoints of the line. Yep. So first thing we need to do is actually consider all of the line segments one by one in order to do this. So these are just in an array of height values, so we kind of need to step through like two at a time, if you like. So what I'm going to do here, so we have these in an array called terrain heights. So normally I'd just do this, right, and loop over every point in this array. Why Java? So one, it's just something for whatever reason in my professional career I happen to be familiar with. Also, I'm using this tool called processing, which is a really nice framework for doing like graphical rendering. It's a very convenient way to get like graphics on screen and audio and like input and stuff like that. If I was doing a bigger project, I would probably use something else, but I also want to focus on like the basics here. If I did this in Unity, then there'd be so much like Unity stuff which I'd have to involve, just because you kind of can't avoid using it. Whereas in this is a bit more old school, right? I'm just literally drawing images on screen at different locations and tracking stuff like more or less manually. This is what's actually happening like under the hood for the most part. So that's why it's kind of the simpler thing. Yeah, Unity is good. Also, the reason I'm using this is because I feel like if somebody's watching this and they do want to use Unity, then this stuff will be fairly transferable. Whereas if I did something in Unity, it wouldn't be so transferable maybe to somebody else using like Python or C or something like that. So if I do it at this fairly low, like basic, really old school, like 90s game programming style, then I feel like people can actually understand like everything that's happening rather than relying on loads of layers of stuff which their engine does for them. Okay, so I would normally just loop over every point in this list, but actually we want to consider pairs of these things, right? So I kind of want to start iterating at this point here, and then consider its neighbor along with it, and then take this point and consider its neighbor along with it. So I don't want to iterate up to this point because it has no neighbor. I want to stop here, but I'm going to consider like the n+1 anyway when I consider these line segments. So I'm actually going to loop up to the length -1. So the start point of this line segment is oh, let's make a convenience function for this, I think, actually. So it's this bit of logic we did, where are we? Here, to figure out the x and y. Let's actually put this into a... Yeah, but you just got to keep at it, right? This thing takes time. You have to stick with it, like, and then you get to the point where you can, everything opens up and you start being able to create your own projects, and anything you can imagine, you can kind of figure out a way to do it, and then it's way more motivating and kind of powerful. But you really need to just put in the time and just kind of just dig into it, really. So, what I'm going to do... In fact, I can just pass that in. Okay, suggest the stream topic is... Yeah, so if you use the select a stream topic thing, I think it says in the description there, right? So today we did a Lunar Lander clone. Basically, and every Thursday we do a poll on Twitter to decide what the next coding stream topic is going to be. So you basically get to add something to the Twitter poll. So if you want to see like a, I don't know, like a Mario clone or some other, like more or less anything within reason, then you can add it onto the poll, and then it has a chance of being voted in as the topic in a future week. So you kind of get to decide what we actually do in one of these coding streams. So now we have this convenience function, Red Dead Redemption clone. Like, I could, you know, we could try and do something like that, right? Like some kind of, it would be like a 2D top-down thing or something, but we could make something sort of like that. But it has to be something I can do within like 4 hours, so I'm not going to be simulating like horse testicle shrinkage and all that other crazy stuff that game did in a 4-hour stream. Okay, so we've now got the start and end points of this line. Okay, we now to kind of figure out if the lander is touching it. So I'm more or less gonna copy some code out of here. So they do the equation for us. Basically, you can use the dot product to kind of construct this normal. And then this u value will tell you how far along from like P1 to P2 it is. Like where this point is, basically. Where this is like 0, this is like, I don't know, like 0.75 or something, and this is 1. This is handy because, you know, if it's like less than 0, then the point's like over here somewhere. And if it's greater than 0, then it's like over here. Greater than 1, then it's like over here somewhere. So let's just keep this over here as a reference. They call it U, but I feel like a T is a more normal term for this, so I'm going to call it T. So x3 in this case is the x of our lander. This is all divided by this. Okay, so this is the square of the magnitude of the difference between these two vectors, which we can actually get from processing. Will do that for us. Vector.sub. This is such a common thing to have to do. Square mag. Mag squared. So probably got some okay, that gives us that value. Let me kind of verbose here. If it's less than 0, it means that we're over towards the kind of start point. It's kind of like the ratio here. It's less than 0, then just need to compare to the start point. If we're to the other side, then should compare it with the endpoint. Otherwise, we're somewhere, our projection is kind of somewhere along this line, which means we need to figure out exactly where that point is, which is what this formula here will give us. So all this is doing, let me actually kind of work this out. Okay, so we've got this line segment and we've got our point that we're comparing it to. So we've figured out the kind of start and the end. And there's our point P. We've then done this, found this sort of normal. That's horrible, can't see that at all. Calculated this normal, which is kind of at right angles here. And then what T is it's kind of how far along we are, right? Where this would be 0 and this would be 1. So to figure out where the closest point on the line is to this, we just need to move from start towards the end, given the ratio of whatever T is, basically. And that's exactly what this is doing here. So we're starting at the start point, and then we're moving by T, which is between 0 and 1, multiplied by the difference between the start and the end. So this is the x and y of like the closest point on the line. Now we still need to work out what our distance is to that, so I'm going to use the built-in functions, why not? Subtract position from cool, so this I think should give us the distance that we're looking for. And we can simply say something like if distance squared is less than the size of our thing here, the square of the radius, then we know that we're colliding. What are we going to do if we're colliding? For now, maybe I will just draw like a red line over this or something. Okay. Something may have gone terribly wrong here, we shall see. Okay, well, nothing is showing up. Are we even calling this method? I bet we're even like clearing the background before we do that. So not ideal, but since I want to see this debugging stuff, I'm just going to do this right at the top. I feel like it may just be getting blanked over. Boom. Nice. Kind of surprised that worked first time. That appears to be doing what we need. Okay, so now we can tell when our little guy's circle is colliding with one of these sections. So now all we kind of need to figure out is that a crash or is that like a successful landing, right? Boom. So So what could cause this to be a crash? So there are lots of criteria that a successful landing needs to have. So I'm just going to kind of check things one by one and say, the first thing is we need to land on a flat ground, right? So if the y coordinate of, you know, this point is not equal to the y coordinate of this point, we know that it's like not flat ground and therefore it's kind of automatically a crash. So if the start point and the end point differ, then we've crashed. We've kind of tripped. Otherwise we say if okay, let's pull this out to a function. I can just return. So Boolean is either true or false. So we're making a bit of code which will determine whether this thing has crashed or not, and it's going to give us back true if it has crashed or false if it hasn't. Yeah. Boolean means it can have two different values, like 1 or 0, or normally true or false is what it stands in for. So we're going to say if these points are on a different level, then immediately that's a crash. So I can just return true here. Boom. Let's say if it's going to have a maximum speed, right? So if the x speed, so if our lander's coming in hot, like too fast this way, or too fast this way, it's going to be a crash. So let's actually put some of these out here. And this isn't going to be like pixels per second, so let's make this 10 for now, and then y. Let's make that the same, and we can tweak these. So this will take our x speed, like our left-right speed, and then abs will make it. It'll turn negative into positives. How did I learn to code in Java? So there's two things to this, right? One is like learning to code, and then one is like learning a particular language. Like a lot of people think they stress about what language they should learn, whereas in reality, if you know the fundamentals of programming, then picking up a new language is really not a big deal at all. So I had already learned to program in some other languages before, and then when I went to university they wanted us to use Java, so I just picked it up and started using it like more or less straight away. Like, yeah, the fundamentals, like loops, you know, what is a Boolean, what is a loop, what is a variable, and then things like what is a class and all of this kind of stuff. Once you have that down in one language, It's like at least 10 times easier to then pick up a second one. Yeah, so learning Java was just not a huge deal, or at least getting to a point where I can okay, right, so if you know Scratch, I mean Scratch really does legit teach you the fundamental stuff. So Boolean is like, I don't know what they call it in Scratch, maybe it's like a flag. Loops, like they have this like repeat thing in Scratch, right? So a lot of that really does transfer over, like knowing exactly where the squiggly brackets and the semicolons and stuff should go. That's just something that get used to, and you can Google it and just copy and paste for the most part. But it's like the logic of how everything fits together, and that's really what I'm trying to like help people out with on these streams as well. So if our Y speed is too much, we've also crashed. So so we need to be moving down at slow speed to land. So if our speed is like, and this is like a positive speed, so going up would be like a negative speed, just given how the coordinates work. So if we're moving up, like we've clipped the terrain like from underneath in a weird way, or if we're moving down but it's more than like the maximum speed we've determined, then that's also a crash. Otherwise, I think we may be okay, right? So the ground's level. So the ground must be level, the X speed must be reasonable in either direction. So must be moving down slowly. If those are all successful, then we can say we haven't crashed, right? We've actually touched the ground and we appear to have landed successfully. So we can say if we've crashed, so in this case we've landed, and we can say we get to a landing state. Otherwise we are dead. We may as well bail out at this point. There's nothing else to be done. We don't need to continue checking other bits for collision if we've died. What happens when we go into a landing state? So we kind of want to play our landing animation. So need to consider our Sitting. Settle is what I meant there. What we're going to say here is if the animation's done, then we just go back to idle. There we go. Should also probably zero out our velocity whenever we touch the ground. Yeah, will this do what we need? Let's check it out. Okay, so one thing I'm not sure of is like the parameters I set for like how slow or fast you're allowed to be going. What I think I may do is I will move this out to a function. I can say if we're not then again as another debug thing I can say if we're moving at landing speed, then I'm going to kind of tint it green. Otherwise I'm going to tint it just its normal color. This is kind of a debug rendering thing. Maybe I'll add a toggle for this as well. But this will let us tune those speeds, I think. Cool. Now we can kind of tweak these a bit more in a bit more an informed fashion. Okay. That's real sensitive. That's a little bit too harsh, maybe. I mean, these old games were pretty damn harsh. Let's say if we're dead, then let's tint ourselves red, just so we have some way of knowing when that's happened. And then let's make this a little bit more forgiving. Nice. Oh, okay, that was not... Okay, I think what happened is it should also put us, like, so we're right on the ground and not quite touching it, I believe. So I think what happens is when we successfully land, we should also set our rotation to 0 and set our... It's going to be equal to exactly kind of kissing on the radius there. Could use start point or end point here, they're both the same because we know the ground's level. Okay. Nice. Okay, got killed there. Oh, Dave, how's it going, man? Yeah, so what we're doing today is we're making a clone of Lunar Lander. I don't know if you remember this old classic. Yeah, so we've got the core thing working now, right? So we are able to have this guy take off. He's got more or less like floaty physics. I can thrust him around in whatever direction. Yeah, it's one of these old school like hard arcade games where the goal is to... Well, there's various forms of it. It's one of these games which is just cloned a whole bunch. The goal was generally to like move from one platform to another. And you'd have like a fuel meter, and it's just kind of hard to land without crashing, to be honest. So that's kind of what it comes down to. So I've literally just got the basic physics working, all the collision detection, and the sort of like little state machine for this guy. Oop. In terms of adding an objective, I suppose something that might make sense is yeah, right now there's no like actual structure to this in terms of like objectives. We've just got the basic like state machine going on. So I think what I want to do to actually turn this into a game in the last like half hour or so of this stream is maybe do something like having screens where on each screen you'd have like a start point and an end point. So you kind of start here and you have to get to the end. Yeah, like everything had a version of this. Like I was saying earlier, like Neopets used to have a version of this. It's one of those old classics. Yeah, so maybe when you get from point A to point B, then it just generates like a new level with like randomized terrain. With like randomized terrain heights. So your score is like how many hops you've managed to do, and you have like a persistent fuel meter. which maybe gets topped up like a certain amount every time you complete a level. So it's about doing it. Maybe there's a timer as well. I don't know, like with fuel efficiency, and then doing as many like different hops as you can. So I think what I would like to be able to do now is to randomize the terrain, so we can actually put that into the logic somewhere. So just going to add something in here. So I think I'm probably going to use... That's what I'm doing, yeah. No, my call system so far is an array hard-coded with a load of terrain heights. But I think what I'm going to do is like a Purlin Noise based thing. So I don't know, you're all like the people familiar with Purlin Noise? Yeah, basically Purlin Noise is like something that will give you a nice like smooth noise function, which I can then sample to kind of generate this terrain. That's kind of how I'm going to do that. It's kind of perfect for terrain type stuff. So let's just say and then I'll have like yeah, I'm sure this may have factored into your thing about camera shake as well, right? I'm sure there was a Purlin Noise version in there somewhere. I wouldn't be surprised anyway. Okay. So what I'm going to do here is okay, I forget the range of Purlin. Is Purlin Noise between -1 and 1? Or between 0 and 1, like by default? Thankfully, this framework I'm using gives us just a noise function like straight out of the box. So you know, we have to figure out like some kind of scale thing here. And then translate that to a height. So zero to 1, okay, yeah. So I now need to map from... Okay, so in this framework I'm using, if this is a screen, then this is y0, and this is y, there's a variable called height. And you know what, I think it even has like a convenience function that will map this for me. I kind of want to cap it at like 80% maybe, just so it doesn't, so there's actually room to fly around and stuff. So I can actually just use this map function, mapping the noise, which starts in a range of 0 to 1, and I want to map it instead to a range from times 0.2 to times 0.8, something like that. Okay, alright. And then I kind of want to create some platforms. Okay, so what this will give me is a set of points kind of like all around here. But what I would like to do is artificially like level off a certain number of these. Like if we want to make a platform, maybe this becomes like level. Or maybe the better way to do it is to take 2 points and like move them to their averages so that we get something like that. Yeah, I think that's what I'll do. So, and we need 2 of these. We need like a left hand and a right hand one. Let's set them slightly off from the edge. I have this thing saying how many like segments wide a platform should be. So let's make a function for this. Make a platform starting at a certain index. A certain width. So I'm going to find out the average. Cliffs are fine. Yeah. I think that's okay. Yeah, it'd be interesting to play. Yeah, I'm just going to get something up there, and maybe we can play around with different algorithms for this. Okay, and then I'll do the same thing and like flatten them off. Okay, I believe that will do what we need. So I will say make a platform starting from like 1. I'm gonna make one on the right. It's gonna start from minus turn points minus platform size minus 1. Okay. Then I kind of place the player in here, and I think the way I'll do that is just going to put him at. So I already have a convenience function to tell me the height of the terrain at a certain point in like world space. See, will this do what I need? That may be it, right? So Let's throw that in there. Probably get some error thrown. Okay, that does not look... okay, so first I need to offset his position by his like radius, but there is actually a slight slope here, so I feel like I've just got my scaling factor when I'm sampling the noise wrong, most likely. So, should actually put him at... y minus... Okay, so a couple of things are not quite right there. Nice. So let's do something here whereby this is going to be horribly hacky. If we're in the right hand side of the screen. I'll just re-randomize the terrain, so that should give us like a progression of a sort. Okay, I just generated the same exact terrain. Oh, you know what would be nice is we could actually move across like legit the same terrain with something like after we do this. Yeah, I may have had an off by one here, but I think this will work and we'll actually see. This is why this game is hard. We should see ourselves just like moving across the same terrain, kind of contiguously. Hey, welcome back. Yeah, we got a lot of stuff happening. So, we got the state transitions in, so we can now take off. So there's a little animation where he takes off, and then he goes into kind of free-flying physics mode. We then implemented a little bit of collision detection logic, which is basically boils down to finding the distance between a point and a line segment, which that allows us to do a bit of basic collision detection to figure out if he's overlapping with any terrain. Then we have another bit of logic which says if he's overlapping with a bit of terrain and it's flat and his speed is below a certain threshold, then he can now land, and we trigger like a landing animation, and we then in fact randomly regenerate the terrain in that case. So boom, there we go. So we've kind of got like an endless scrolling thingy going on here. So I think the last little thing I'm going to add at this point is some kind of like score keeping mechanism, and maybe like a fuel counter. But this is kind of Lunar Lander, right? Like we're basically there at this point. Core gameplay is there in about 2.5 hours or so. I'm going to turn this debug circle off as well. I'd also like to maybe color the platforms in differently. What happens when you land on a slope? He just turns red and kind of stays there. It's just, that's a fail state. Yeah, I don't know if I'll get far enough to like adding lives and stuff like that, but yeah, that's game over at that point pretty much. So I think what I'll do is give him a fuel gauge. And then I'll do something like, where's my thrusting? Add another parameter for fuel consumption rate. How long should we be able to thrust for? Like, I don't know, like 30 seconds? Then we should probably render this somewhere. I got HU. I got a mix between UI and HUD there. UI, there we go. Okay, see you, Dave. Take care, man. Okay, we have a little fuel meter. Let's now fill this up. Okay, one issue is that our fuel gets reset, so this is real hacky. I instantiate my lander every time rather than like dealing with resetting its state. But one thing I do want to carry over is its fuel. Ah. Yeah, this is real hacky. I don't like this at all, but it will do. So now our fuel should be persistent. Actually, have our score here as well. Let's draw our score. Just guessing at 20 there. Okay. Should probably also update the score when we complete the level. So we can only thrust if we have fuel. I should make that a thing. Okay, limit the fuel so it never goes below 0. So I'm kind of hacking in a load of stuff super quick now, but we're almost where we want to be. But one thing, it looks like it doesn't care about our angle too much, which is not ideal, right? We shouldn't be able to land like that, so let's add another. If maps of arbitrary here, let's add a variable for that. Yeah, that's actually a reasonable angle it lets us get to. Maybe that's too much. Like, landing should not be easy. It's kind of the point of this game, so I'm gonna drop down these thresholds a bit. I'm gonna get rid of his circle. don't know if I'm just kind of good at this or if this is too easy still. I suppose doing it with maximum fuel efficiency means like flinging yourself over and then like just coming to an immediate stop without all this faffing around and wasting fuel and stuff. Yeah, I did not like that. What would be kind of cool is to have an indicator of our... I bet the game already did this, you know, the original one. Yeah, like this thing. Oh yeah. Oh man, Kerbal Space Program is one of my all-time favorites. Yeah, it's very Kerbal. What I'm thinking and what I'm think this probably is like an indicator which shows me how I'm doing along the various axes. So I feel like having an indicator of my speed would be nice, and I kind of want to picture this as like a semicircle, because you need to be moving like down within a certain threshold and left. So you know, if you're going too far to the right, then maybe you're a point out here. Yeah, maybe I'll draw this as like a vector. If you're going too quickly downwards, you'll be here. Whereas if you're like in the zone, then you're at an acceptable kind of velocity. Although actually it's not a semicircle, right? It's actually just a rectangle. Given the way the actual constraints work. So let me try and draw something like that. UI. So we have the fuel indicator. We have the score. Let's have the velocity as well. So I think what I'm going to do is... Okay, so... let's keep the plain white color scheme, and then going to draw a rectangle. Minus... see how this looks to us. Okay, so that's the box there. I then want to kind of draw a... If it's at a reasonable speed, then we're going to say draw a green line. Otherwise we're going to do this in red. I'm sure there's a proper like kind of indicator that NASA use for this kind of thing, or like pilots use, but we'll make something up here. Then I want to draw a line from it's kind of a bit hacky and hard-coded here, but it should be okay. So that's going to be this like start point here, and then I want to draw a line based on the velocity and in comparison to those thresholds. So let's say plus 50 times divided by and the y is going to be 10 plus what was it, 100 times lander dot velocity dot y divided by is hitting my threshold of messy hard-coded code here, but get this done. Okay, all right. Probably missing a bracket around here. I think the way I'll do that actually is, it was weird, most of the time it was kind of off the top of that box, so I think I will actually do something more like this. Where I kind of draw like a green area. Kill my speed in that axis. Cool. Yeah, I feel like that indicator is at least somewhat helpful. Yeah, there's definitely a riskier strategy of like flinging yourself over super fast, which actually uses less fuel. overall. So if you're really smart, you'd take like a ballistic trajectory. Let's see if I can pull this off. And then just like kill your velocity as you come in. Ah, too fast. I'm kind of running out of fuel here, so I have to be a bit risky this time. And I'm out of fuel. Cool. Okay, I'm actually going to try this one more time because I kind of want to beat my score there. But I think this is where we'll leave it today. We've got something pretty functional, like this is actually a game of sorts now. There's some cool stuff we could do with progression, like we could scale the terrain generation in some way based on what level it is, so it gets more extreme or something like that. Ah. Okay, one more go. And I think, yeah, the randomization also has a appreciable impact on the difficulty or like the trajectory you might want to take. Okay. I want to try something out here. Okay, I think I've gone off by one somewhere. What I wanted to do is have it so that when it randomizes, it steps across so that so it's sampling from like a Purlin Noise field, but it would cause the terrain to be kind of consistent. Okay, yeah, I think we got it there. So we should be on a flat platform and then a downslope. Yeah, flat platform with an upslope. Yeah, cool. So it's almost effectively just like scrolling the map along at this point. And you could even like have that visually happen, I suppose. Yeah, it feels more like a journey across the terrain of a alien world here. The ambient music I've got going on is actually kind of fitting as well, right? Ah. Yeah, it is very Kerbal-like. It's kind of tricky at that last moment to just get that speed right. You spend so long like finessing it in on the approach, but then yeah, it's gonna stay within that threshold. No. So it's just like it's all like screen space. So there is no center of the planet or anything like that that's being accounted for here. It's just a constant, which I just arbitrarily set based on tweaking some numbers to see what felt right. Which is kind of lazy, but I feel like that's also the right way to do this kind of thing, really. It's all about how it feels. I'm kind of trying to replicate how I remember the original Lander game's feeling in a way. Come on, I've got to beat 5. What could be cool is like you know, like Mario Galaxy, where it's all on a circle. We could have this thing like wrapped around a circle so that you're always being pulled in like towards the center. I could imagine that being quite fun. Oh god, where am I? Oh no! It's also not a game for the impatient, is Lunar Lander, because the possibility of just flinging yourself off into oblivion is ever present. Yeah, there's no way I'm doing this. Just wondering, looking at this sprite sheet, is there a frame where he's flying, but his pack isn't on? Why am I doing this? Okay, I can't resist. I'm going to make it happen. So we have the pure floating NG there. Yeah. That could also work. Yeah, I love the whole thing of transferring from you know, whatever's the greatest influence and sort of yeah, that's a cool thing. Like Mario Galaxy did exactly that, and it was just super satisfying to like just move and jump around in. I'm sure somebody's made like I guess you got like a radial lander. Let's find out. Unless that's an actual thing. Maybe not. You know what? Maybe that's like a stage 2, right? Maybe that's maybe that's part 2 of this project. What was I doing here? Yeah, okay, I had another animation for... Zero, 1, 2, 3, 4, 5, 6, 7. So what I'm doing here is just having it change animation based on whether or not I'm holding the thrust button at the moment. Right now, his jets are kind of always on. Whereas in reality, that's not actually the case. This is really just fiddling at this point, but kind of a little graphical thing that was annoying me. That should mean now that if I let go, cool, he just floats around like a... Kind of looks like a guy in a spacesuit. Hey, man. No, that's cool. Yeah, like everyone forgets how to do stuff if you don't practice it all the time. Over time, the stuff that you end up doing a lot, you'll become familiar with and you'll know by heart, but it's fine to like have to look stuff up and figure things out. And you kind of end up with a library of like little projects where you've solved different problems and you can kind of go back to those, right? So if you're trying to figure out how to do this in future, you can refer back to your little clicker game and hopefully it all comes back to you. I much prefer this now that he's floating like loosely in space like that. It looks much more lonely and spaceman-like. I've wasted loads of fuel here. Can I get the 6? It's also terrifying when I go off screen because I have no idea where the hell I am. Oh no. Okay, I'm actually genuinely kind of having fun with this right now. But it is about time to wrap up, I think. So if anyone's not following on Twitter, then probably good thing to do since we post a poll every Thursday for the new topic. So you may have noticed also we just got Twitch affiliate, and one of the channel points rewards at the bottom under the chat there is to suggest a new topic for that poll. So if you have the points, that's something you can also do. Otherwise, if you're not part of our Discord, I will throw the link in here. So there's the Twitter. And there's our Discord if you want to actually check out the game that this character is a part of. That's where you can do that. And I'm just going to have one more go to see if I can beat my high score of 5. Ah, that's it. Awesome. Thank you. Yeah, I'll catch you tomorrow. Catch you tomorrow, Max. Okay, thanks everyone for tuning in. I could not beat my high score, it seems. But we will check you next time.